Good morning, everyone. My name is Lorena, and I'll be co-hosting today's webinar. Thank you for joining us today. Before we get started with our webinar today, I want to remind everybody that we want today to be interactive, so we're going to be using some of the tools, and I'll walk through those before we introduce the instructor. But today we'll be covering a few energy efficiency tips and things to consider if you're a small to medium-sized business. And we hope that you'll be able to apply some of these at your facility to save energy and money. We also want to thank our sponsors, Energy Trust of Oregon and Northwest Energy Efficiency Alliance, which you'll see their logos on the bottom. Based on our customer feedback, they appreciate that we help to offer trainings together so that it keeps us aligned to help eliminate any confusion regarding energy efficiency or renewable messages that we communicate to our customers. Again, you'll see to the right side of your screen, you'll see a chat window where you can chat any questions to me or any issues that you run into throughout the session. Let me know. Right to the left of your screen, you'll notice right under the Quick Start menu where I'm going to draw this red line, you'll see some tools. There's a pointer, a T, a highlighter, an eraser, and those are the tools that you'll be using today. We want to make it interactive, so the instructor will let you know when to use those throughout the session. I'll introduce Garrett. Garrett is a commercial energy specialist with PGE, and he has over 10 years of experience in educating and advising customers on energy efficiency technologies and any types of upgrades that you can do at your facility to save energy and money. He also works really close with the Energy Trust of Oregon and to provide information to customers on incentives and any tax credits that are available for each year. He has a degree from Lane Community College in Energy Management and has a business management degree from Lynn College. So Garrett, we'll go ahead and get you started here.
Good morning. Before we get started here, I just want to quickly go through our agenda. First off, we're going to talk about some basic calculations, calculating energy use for equipment. Also, just kind of general covering of business energy use, where different types of businesses use energy, whether it's lighting, HVAC, and so on. Then talk more specifically about lighting opportunities. What are some areas to look for? What are some technologies to address? Same thing with HVAC, heating and cooling systems. We'll also cover low and no cost ways to save energy, so things that, when we're done with the seminar today, you can put into practice right away. And energy trust incentives that are available to you as a PGE business customer. And kind of getting started, next steps, what you need to know to move forward if you identify some good opportunities. So first we'll talk about energy and power. So power is basically the rate at which work is done, and that's watts. And energy is power over time, kilowatt hour. Kind of a comparison would be with a car, your horsepower, and energy is how many gallons you use. With electricity, it's kilowatt hours. That's the unit of consumption. So we'll go over some basic calculations here, calculating energy consumption. So calculation is watts times hours divided by 1,000. That gives you your kilowatt hour consumption. So in this example, we'll look at a 100-watt incandescent light bulb. So 100 watts times 2,920 hours, which is 8 hours a day, 365 days, 1 year. You divide that number by 1,000, and it gives you 292 kilowatt hours. So basically, that's the amount of energy that a light bulb would consume 8 hours a day for a year, 365 days. And here's just basically the same concept and maybe an easier to grasp a graphic. So 100-watt light bulb multiplied by 2,920 hours divided by 1,000 gives you the 292 kilowatt hours. So now we know how to calculate the actual consumption. We'll calculate cost. So PGE's billing unit for energy is kilowatt hours. Our a typical small, mid-sized business is likely going to be a Schedule 32 business customer, and the rate there is going to be about 8 cents a kilowatt hour. So just going over the numbers again, to get kilowatt hours, 100 watts for the bulb, times 2,920 hours divided by 1,000, 292 kilowatt hours. So the cost to operate, we just need to plug in the rate, multiply the kilowatt hours by the rate. So 292 times about 8 cents a kilowatt hour gives about $23.50 a year to operate. And again, here's just a graphic of the same concept. 100-watt light bulb multiplied by the hours divided by 1,000 times the rate, and we get $23.50. So we'll go through a practice problem here. And just one more review again, watts times hours divided by 1,000 equals kilowatt hours. Kilowatt hour cost is about 8 cents a kilowatt hour. So we'll calculate the consumption for a 20-watt LED, which has roughly the equivalent light output to a 100-watt incandescent. So how much does it cost to operate that 20-watt LED for 2,920 hours? The hint there is the formula at the bottom. So if you at your desk want to plug in the numbers and get a kilowatt hour number and a dollar amount number, I'll let you go ahead and do that. So remember, the tools are on the top left-hand side of your screen. Once you plug in the numbers, if you could go ahead and just indicate with any one of the tools what the cost is going to be to operate that LED lamp, and I'll give you a few moments to do that. So it looks like we got a couple responses there. So yeah, the correct answer is about $4.67. So you can use this to calculate different equipment. It isn't necessarily just applicable to lighting, but other equipment as well. So putting it all together. So 100-watt incandescent, we're looking at 100 watts times the hours divided by 1,000, 292 kilowatt hours. Compare that to the 20-watt LED, 20 watts times 2,920 hours divided by 1,000, 58 kilowatt hours. So basically, it's going to cost you about $23.50 to operate the incandescent, and about $4.67 to operate the LED lamp. So replacing one 100-watt LED, 100-watt incandescent with a 20-watt LED saves about $18.82 a year. So pretty significant. And I know it's early this morning, and you probably didn't think that you were signing up for a math class, so there will be no more math. We'll move on to some more kind of basic high-level slides. But the calculations are kind of a good foundation and good to know in terms of looking at energy consumption in your facilities. We'll cover business energy use, so the top 6 uses of commercial electricity in the United States. Just what I wanted to point out here is that lighting is typically the biggest consumer. But you start adding space heating and space cooling, and it comes in a relatively close second. So those are generally the 2 largest consumers or end users in commercial buildings. So here's a breakdown of office building energy use. So this is not just electricity, but any fuel source. So other sources may be natural gas heating or oil heating or other fuels. So even figuring all that in, lighting is a pretty big percentage, 23%. Space heating and cooling are also pretty significant as well. But when you're just looking at the electricity side of it, lighting is a really big chunk, about 46%. Space cooling and ventilation, HVAC, that's pretty significant as well. Also kind of rounded out by office equipment, plug loads, stuff like that. So retail, you can see that lighting is pretty significant here. Retail spaces tend to have really high light levels if you're selling product, maybe a lot of halogen lighting, high energy consuming lights. So even factoring in all the other energy fuel sources, lighting's pretty significant, 55%. And then looking at electricity alone, almost 60%. Again, space cooling, ventilation, HVAC coming in second there. So warehouse, again, pretty significant lighting load. Total energy about 32%. You see a lot of space heating needed for warehouse space, usually like gas unit heaters, so it's going to be pretty significant there as well. But just looking at the electricity side of it, 56% of electricity typically goes to lighting in the warehouse space. So there's a lot of lighting opportunities, and why upgrade lighting systems? Well, first and foremost, save energy and reduce operating expenses or utility expenses. Reduce maintenance costs. One of the kind of non-energy benefits of a lot of lighting projects is you get a lot longer lamp life out of the newer lighting technologies compared to what you may have in your business right now. So just the maintenance that goes into replacing lamps and ballasts and that kind of thing, good opportunity there. Improve lighting quality in workspace and retail environments. So in an office space, for example, if you're able to get appropriate light levels, higher quality light levels, studies have shown that workers are more productive, they're happier when they're working. In retail, it's displaying your product, and if you're able to get better light quality there, hopefully it's going to help sell whatever you're selling at your business. And it's often one of the largest areas of consumption, which we've seen in the previous slides. And it also tends to be a very cost-effective upgrade for a lot of businesses. So one of the most common types of lighting that's found in commercial spaces is linear fluorescent. So T12 is a older technology. They're the inch diameter tubes. They operate off magnetic ballast. T8s are the inch diameter versus the inch and a half for the T12. It's newer technology. It's kind of today's standard. It's going to be much more efficient. So you can retrofit these T12 fixtures with T8s. You're going to improve the light quality. So color rendering index is kind of one of the measurements of light quality. Its ability of artificial light to kind of display colors accurately. So much better with T8. You're going to see a lot longer lamp life with T8 versus T12. Typically, high performance T8s anywhere from 24 to up to 50,000 hour lamp life. Standard T8 is going to be closer to 20,000 hours. So when I work working with customers, what I typically see for a payback in terms of recouping out-of-pocket costs, anywhere from the 2 to 4 year range. And we have T12 phase-out, kind of federal phase-out of T12s. Most of the common T12 lamps are no longer going to be available. There are some kind of loopholes in the law that are going to allow some lamps to be sold, but probably a little more expensive than we've seen in the past. So we'll show you here a linear fluorescent office example, retrofitting T12 fixtures with T8 fixtures. So this might represent a small office that has 24 130 watt 3-lamp T12 fixtures. And the lighting upgrade would be retrofitting these fixtures, these 24 fixtures, with 55 watt 2-lamp T8 fixtures. Hours of operation, 10 hours a day, 5 days a week, and then 4 hours a day on Saturdays. So annual energy savings, you'd be looking at nearly 5,000 kilowatt hours, and dollar savings, about $413 a year. Energy trust incentive, $720. Simple payback after incentives of 2.3 years, and a pretty good return on investment, 43%. So high bay lighting. High bay lighting is often seen in warehouse space, maybe automotive repair. A lot of big box stores will use high bay lighting. So the opportunity here is to replace either high pressure sodium, which is the yellow colored light, or metal halide, which is more white, with a fluorescent fixture. So the fixtures to the left here could be metal halide or high pressure sodium, and the picture to the right is a warehouse space with some high bay fluorescent fixtures. So you're going to improve the light quality, the kind of color rendering index when you move to a fluorescent light source. You can utilize occupancy sensors. So with these metal halide or high pressure sodium, there's warm-up time. If you've ever seen them, it's going to take maybe 5 minutes to get up to full light levels. You can't really utilize an occupancy sensor very well with these. With a fluorescent, you can. Typically, it's a fixture-mounted occupancy sensor. So if you were to walk down the aisle in this picture and had occupancy sensors mounted on these fixtures, basically when you move forward, each individual light would be turning on. So it can be really appropriate for a lot of spaces and add some additional energy savings. Typically, just the wattage alone, you're cutting the wattage in half going to a fluorescent light source. So typical payback, usually see in the 2 to 5 year range. A lot depends on hours of operation and so on. There's a lot of factors, but that's kind of a typical range. And what we have here is just another example of a potential project. Existing lighting for maybe a small warehouse, 20 461 watt metal halide high bay fixtures. The upgrade is replacing these fixtures with 20 222 watt fluorescent high bay fixtures with occupancy sensors. So they're on 10 hours a day, 6 days a week. Annual energy savings, almost 18,000 kilowatt hours. Annual dollar savings, about $1,500, rate schedule 32. And the energy trust incentive would be about $2,400 for this particular project, resulting in a payback after incentives of 2.1 years and a return of investment of 48%. LED is another good opportunity. LEDs are seen in a lot of retail space, restaurants, food service. You can replace halogen track or can lighting with LED. So you're going to see a much longer lamp life with the LEDs. Typically, it's 25 to 50,000 hours. And to kind of put this in perspective, one LED lamp is going to last as long as maybe 12 to 25 halogen lamps. So there's a really good case to be made, just on maintenance costs alone, to replace halogen with LED. But of course, there's big savings too on utility costs. There's dimmable options for LED. It's kind of an emerging technology. A lot of different products is out there. Typical payback is 1 to 3 years. I see in retail space or restaurants that because of the long hours of operation, that this is often very cost effective. We have an example here of, could be a retail or a restaurant space. Existing lighting, 40 MR16 35 watt halogen track lamps. So these are the relatively small halogen lamps, and replacing these with 40 MR16 5 watt LED lamps. So we plugged in a little longer hours of operation here, 12 hours a day, 7 days a week, which gives us annual energy savings of about 5,124 kilowatt hours, dollar savings about $428 a year, energy trust incentive of $600, and a simple payback of just 1.4 years, and return on investment 71%. So looked like that would be a really good project, and typical of a lot of smaller restaurants and retail businesses. So exit signs, the opportunity here is to replace incandescent or fluorescent exit signs with LED. You're going to see much longer lamp life with the LED, maybe 50,000 hours, and incandescent is just going to be maybe a couple thousand hours. Even compact fluorescent, you're just looking at maybe 10,000 hours. So payback is maybe 1 to 2 years. It's not going to be typically a major consumer at most businesses, but it's very, very cost effective, and the lights are on 24/7. And those long hours make projects really cost effective. There also can be an opportunity with existing T8 lighting. So if you have older generation T8 lamps and ballasts, there's potential to replace the lamps and ballasts with high performance T8 lamps and ballast. It could be a matter of reducing the number of lamps depending on the light levels, or just going with same number of lamps, low ballast factor ballast, reduced wattage lamps. So you get a higher color rendering index with this particular upgrade, longer lamp life. Typical T8s are about 20,000 hours, and again, high performance T8s or reduced wattage T8s upwards of 24,000 hours, going up to potentially 50. So it's an option when existing ballasts are older than 10 years or space is overlit. So there's kind of a few options. If you have ballasts that are maybe 10, 15 years old, they're starting to fail, you can spot replace. There aren't going to be incentives to do that kind of upgrade, and it's going to be an ongoing maintenance issue. But if you looked at it as a project where you're really evaluating the appropriate light levels of a space and quality light and on all of that, you could look at it as a project. You can get incentives and take care of a lighting maintenance issue and see some energy savings there. Also get great opportunity when the space is significantly overlit. Typically, you're looking at foot candles as kind of a light measurement for office space. You're looking at recommended kind of standard is about 30 to 50 foot candles. I've been into spaces that have close to 100 foot candles, so huge opportunity there. But typically, you can see at least 25% savings when upgrading older generation T8. Occupancy sensors. Occupancy sensors can work great in areas with intermittent use. So this could be individual offices, bathrooms, maybe a stock room for a retailer. So the concept here, you're just basically reducing lighting operating time. Payback is typically 2 to 4 years. So we have several types of occupancy sensors here. The first type looks like a fixture-mounted occupancy sensor. This is something that you might see on those high bay fixtures that we talked about a few slides back. Moving to the right in the middle, looks like a ceiling-mounted occupancy sensor. And then to the far right, the larger picture, that's just a switch-mounted occupancy sensor, so replacing a switch. A lot of times you'll see this type of occupancy sensor like in individual offices. So we'll have another exercise here. So what are your lighting opportunities? We've talked about a lot of potential opportunities, and if you could use your tools at the top left of the screen and maybe indicate some of the potential opportunities you have at your business, at your facility, to make some upgrades or to investigate. So I'll give you a few moments to maybe select a few. So go ahead and do that if you would. All right, so it looks like we've got a little of everything out there, which is really representative of commercial customers. There's a number of lighting types, and I find a lot of businesses have kind of opportunities that are found here, and often multiple opportunities. We'll move on to HVAC. Rooftop units are probably one of the most common HVAC unit types for small and mid-size commercial businesses. Typically, it's natural gas with air conditioning. So basically what we have here in the picture is AC with a gas furnace, air handler, all in one unit. It's on the roof, connected to duct supply and return ducts. So the opportunity here is to replace units with high efficiency models at end of equipment life. Typically, it doesn't really pencil out to replace functioning equipment. But when you look at end of equipment life, looking at standard efficiency versus high efficiency equipment, potential savings, standard versus high efficiency on the cooling side, about 5 to 15%. Not a lot of savings to be had on the gas side. You're mostly looking at cooling gains there. So split systems, heat pumps and air conditioners, these are typically in small and mid-sized businesses, more residential size equipment. This happens to be a heat pump outdoor unit in the picture to the right. So replacing these split systems with high efficiency models at end of equipment life, again, much similar to the rooftop units. That's the time to look at the high efficiency options. Potential cooling savings, 5 to 15% standard versus high efficiency options. On the heating side, with heat pump, again, roughly 5 to 15%. So combustion furnaces, probably most commonly this is going to be natural gas. What we have here is a picture of several gas and oil burning units. The units on the end are condensing units. They have the white PVC pipe, secondary heat exchanger. They're going to be high efficiency units. Units in the middle, the three in the middle are just kind of standard efficiency, probably 80% or so. So replace combustion furnaces with high efficiency condensing models at end of equipment life. Potential savings, 5 to 15%. A lot of the natural gas equipment you can get around up to 95% efficient versus maybe 80% for older equipment. So combustion unit heaters. Typically, you'll see these in warehouse space or automotive repair facilities. This picture here happens to be one in a retail environment, so sometimes you'll see that. So the opportunity here is replace unit heaters with high efficiency models at end of equipment life, or replace with radiant heaters. A radiant heater wouldn't work real great in this retail example, but it might in a warehouse environment. You don't have to heat the entire shop or warehouse with a gas unit like this. You could use radiant heat. Radiant heat is heating an object, so maybe it's just at a workstation that somebody's at most of the time. So potential savings going from standard efficiency gas unit heaters to high efficiency unit heaters, 10 to 25%, and potential heating savings going to radiant, potentially up to 60%. Another relatively common commercial HVAC air conditioner heater would be a package terminal air conditioner. So recommendation here is replace PTACs with package terminal heat pumps at end of equipment life. So typically these units, you'll see them in like hotels or motels, but sometimes in offices as well. The opportunity is to replace these, and they usually use electric resistance heat, and heat pump unit is going to be much more efficient. So potential cooling savings, 10 to 25%, and potential heating savings up to 50%. Big jump there going from electric resistance to heat pump option. And typically, a heat pump's not going to be much more expensive compared to just an AC with like electric resistance heat. So good opportunity at that time. So some smaller businesses are using electric zonal heat. You can replace zonal electric heaters with ductless heat pumps, potential heating savings up to 50%. So for those of you not familiar with ductless heat pumps, they've been around for a long time. They were developed in Japan probably over 50 years ago. And the concept here, as the name implies, there's no ducts. So this is a picture of an outdoor unit to the left. So it's in the winter, picking up heat from outdoors, moving it inside to the indoor unit. It's kind of hard to tell the perspective here, but this is an indoor unit mounted towards the top of a ceiling. It's probably about 3 feet wide, a foot tall, and it acts as kind of like a mini furnace. And with these units, you can have one, and typically in kind of residential size units, you're looking up to 4 indoor units. So good for spot cooling, improving the efficiency of your heating system, and good for a lot of small businesses. So some low and no cost lighting opportunities, things that I've seen out in the field that are kind of problems, dirty photo cells on exterior lights. So often exterior lighting, parking lot lighting or exterior building mounted lighting is operated by a photo cell. So when it gets dark, the lights turn on. When the photo cells get dirty, the lights remain on during the day. So it's just simple maintenance, cleaning the photo cells. Opening up the curtains and blinds to maximize daylighting, especially this spring, summer, fall. You can benefit from natural daylight. Installing compact fluorescent lamps in more residential style fixtures that sometimes you see in businesses. I think most people are probably using these at home these days. They're low cost and very cost effective. And just turning off lights, simple things like that in occupied rooms. I'll move on to some low and no cost heating and cooling and water heating suggestions. So installing programmable thermostats. There's still a lot of manual thermostats out there, and unless you're very diligent about setting back the settings or forward and cooling ahead and cooling side, you won't realize the savings you potentially could with a programmable thermostat. They're low cost. Ensure existing programmable thermostats match the occupancy schedule. So a lot of times the manuals have been lost and no one knows how to operate it. Usually your HVAC contractor should be able to help out with that. A lot of times I've found you can find old operating instructions for thermostats online. And so at PGE, we have kind of optimized thermostat set point recommendations. Occupied, we suggest heating to 70 degrees and cooling to 74 degrees. Unoccupied, so nights and weekends, cooling to 80 degrees and heating to 60 degrees. So anytime you can up the setting on cooling or lower it on heating, you're going to see savings. So just kind of go as far as you're comfortable with. Schedule employees to work the same shift to reduce occupied hours. So limiting everybody to the same 8-hour shift per day instead of having like a 4-hour overlap. It reduces the time the HVAC equipment's going to be on. Also going to benefit on the lighting side too. Scheduling janitorial staff to work during occupied hours. So you don't have those few extra hours in the evening that you typically see where lights and HVAC are going to be on. Perform regular maintenance on HVAC equipment, so making sure that filters are clean, the system has a proper refrigerant charge, airflow. So not only from an energy efficiency perspective, but also for durability, longevity of equipment. And reduce water heater temperature to 120 degrees. Typically, a business is just going to have not a lot of water heating load, just a sink in a bathroom. Or maybe small kitchen, and 120 degrees is just fine. So moving on to plug loads. Just a few suggestions here. I take an inventory of plug loads. See what you have out there in in your space. There's an inexpensive metering device that's available from the Energy Trust. The brand is Kilowatt, and you can check these out at public libraries. So basically, this is just a device that plugs into an outlet. You plug other devices into it, and it tells you, the watts it's consuming and energy that it's consuming over time. So just a way to get a better sense of how much your plug load equipment is using. And the wattage is listed on most devices. So you can, from our calculations earlier in the webinar here, you can plug those numbers from other equipment into the formula and calculate the cost. Perform after-hours night audit. So, after everyone's left, look at what commonly used personal and equipment is used. Are all these devices needed? Can you unplug some of the unused electronic equipment? Sometimes you'll go into an office and somebody may have like a future waterfall on their desk. Do they need that? And do they need it especially at night? So just kind of taking an inventory and evaluating what needs to be used and what doesn't need to be used. So limit the use of high-consuming electric personal appliances. Once you kind of evaluate what's out there, what do you want to kind of ban, or what do you want to allow? Turn all personal appliances off at night. Set PC and other equipment energy management settings to maximize savings. So a lot of equipment, they have energy-saving modes. PCs, it's very common. So just taking advantage of those settings. And replacing personal electric resistance heaters with electric radiant heaters. So actually here at PGE, we've kind of banned the use of electric resistance heaters. So these are the little, plug-in standalone unit heaters. Maybe they're 1,000 watts or 1,500 watts, and they're used under desks. The alternative is a radiant heater, which is just heating the person's body, or legs under the desk, and they're maybe just using a couple hundred watts. So that's a good way to make sure everyone's comfortable, but not having a huge energy penalty for doing so. So Energy Trust of Oregon incentives. The Energy Trust of Oregon is an independent nonprofit organization. Really what they do is promote energy efficiency and offering PGE customers incentives to do so, cash incentives. So the Energy Trust was created by a Senate bill and funded through a public purpose charge. So as PGE customer, on your monthly bill, you're paying a small percentage of your bill in the form of a public purpose charge. PGE is just collecting that funding, passing it on to the Energy Trust, and the Energy Trust in turn is offering these incentives to you as a business customer to make energy efficiency upgrades. So it's something you're paying into. I really recommend that you evaluate what you have and take advantage of the programs that are for you to use. So PGE has a close partnership with the Energy Trust, and we're available as a resource to help our commercial customers, to help them participate in Energy Trust programs. So that means identifying potential projects, prioritizing, offering help as far as next steps to participate, getting projects pre-approved, and so on. So we have just a short list of kind of example projects or incentives available through the Energy Trust. So lighting retrofits have incentives. So whether it's a retrofit of existing fixtures replacement or controls upgrades, occupancy sensors, HVAC upgrades, equipment geared especially towards grocery equipment, refrigerator replacements and recycling. So a lot of businesses have really old refrigerators. Maybe costing a couple $100 a month to operate. Newer units are maybe $40, $50 a month to operate. It's actually really cost effective. PC power management, so software upgrades for PCs that maximize energy efficiency of the units. Insulation incentives for businesses that have uninsulated walls and ceilings, roofs. There's specific lodging and food service equipment incentives, so maybe it's exhaust hoods or gas fryers or refrigeration equipment. Custom projects as well. So this webinar is geared more towards the small and mid-sized businesses. Some larger businesses will have custom projects, maybe chillers, boilers, complicated large HVAC systems require engineering analysis and custom incentives. The Energy Trust looks at multifamily properties with 5 or more units as kind of a commercial business, and incentives for insulation, windows, appliances, common area lighting, so a lot of incentives there. And new construction and major remodel. If you're looking at maybe building a new facility or getting an existing facility, major remodel, Energy Trust offers design assistance, incentives to go above and beyond code, incentives to go with a LEED certified building, for example. So just one note here, most projects do require pre-approval, particularly for lighting projects and, of course, for any custom projects. So just make sure that you understand the programs and before you purchase equipment and make any upgrades, so you can ensure that you get some incentives. And again, we can help out with that as far as the process and determining what might qualify. So kind of next steps or taking action here. So maybe here's some things you can consider doing. Track energy consumption and set goals. So kind of reviewing your historic consumption, comparing year to year, comparing the same months or month to month. Review and implement some of the low-cost suggestions that have been offered here today. Ask PG about your potential projects and incentives. We're here to help you identify and prioritize. And engage your employees in assign tasks. So, kind of getting buy-in and everybody motivated to take an interest in, addressing, utility costs and energy efficiency. So maybe it's assigning someone to investigate with PGE and someone else to look at the low-cost suggestions, but just getting folks involved. So you can receive a free energy efficiency consultation from PGE. So again, just identifying opportunities, next steps. We're available on just over the phone to answer simple questions, or if you need someone to stop by and work with you on site, we're available to do that. So there's our web address there, and my contact information. That's my direct phone line here if you have questions after the webinar today. And here's an email address that you can request an energy efficiency consultation as a business customer as well. That'll about do it. So I'm going to pass it back to Lorena for some questions, I think.
Thank you, Garrett. And I did want to remind everybody, Garrett mentioned about monitoring your energy usage. We do have an introduction to energy monitoring for energy savings webinar on October 10th. If you want to join us on that, we'll give you ideas on how you can monitor your energy. And you don't have to purchase anything expensive. There's some simple ways that you can do that from your facility. So there's that webinar. And again, thanks for joining us. We will be going through the questions, but before that, I wanted to open the poll here to the right of your screen. If you can just take a couple of minutes while we're addressing the questions to give us your feedback for today's webinar. And then also, I think most of you who have registered for this found out we have a new Energy Education Center. Visit that website to sign up for more sessions. Or if you happen to miss any of our sessions, we'll have our recordings up there that you can download as well. But again, we'll send you the PDF of the material and the recording of this session after, within a few days, so you'll be able to get that information. And Garrett, the first question that came through was, if somebody wanted to replace, let's say they have a T12 lamp with a T8, would they have to change the ballast?
Yeah, so the lamp, a T12 lamp is designed to work with a T12 ballast, typically magnetic, and a T8 lamp is designed to work with a specific T8 lamp and ballast. I guess the answer to the question is it might work, probably not for very long, and you won't be saving any energy by just replacing the lamp. So really the right approach would be to look at it as a retrofit. And you know, it's a little more involved, but you can get incentives to make that upgrade, and it's really the right approach to upgrade the fixture.
What is a typical return on investment to upgrade from an incandescent to LED? Do you have an idea?
ROI, I mean, I guess anywhere from 25 to 100%. I mean, sometimes the payback is less than a year, and it's really quick return on investment. So it depends on a lot of factors. It could be the hours of operation, cost of the project, and so on. But typically, it is pretty cost effective. I'd say better than 25%.
Okay, and you mentioned that you have PGE services and Energy Trust. Can they help you calculate and do paperwork for incentives and get ideas on what they can do at their facility? In other words, do you go out there and help them with that, or how does that process work?
Yeah, so yeah, like I said, we're available as a resource. So all you need to do is contact us, via the web or me directly. What we can do is help you, kind of take a look at what you have at your facility on site, make suggestions, areas to focus on, kind of primary areas, cost-effective areas, and then kind of next steps if you need help, what's the process? I need to get this pre-approved. What contractor do I need to work with, and so on? Where do I need to buy equipment? We can help out with that.
And if you send a contractor, does that cost the customer?
No. It doesn't generally cost anything to get quotes for lighting upgrades, for example.
Okay. The question here is, let's see, it says, I've heard that there are little devices that you can point at light to be able to tell what type of lamp it is, like T12, T8. Can you talk a little bit about that? I guess some people are having challenges with that in that area.
Okay. So yeah, there is a device called a discriminator, and basically you point this device at a fixture, and it's as simple as what color is the light that lights up. If it's red, it's indicating that it's a magnetic ballast. And if it's green, it's electronic. It does get tricky sometimes. This may be what the question is referring to with some kind of hybrid, older magnetic electronic ballast, where sometimes you don't know exactly what it is without taking ballast covers off. But generally, this device is pretty effective, works well in identifying the ballast type and obviously the lamp type used.
Where can you get one of those, or can you also check one of those out? Or
I don't think this is something that you can check out. I haven't purchased one recently. I think they're available online. I just haven't purchased one myself. I believe they're relatively low cost. Not something that I think costs hundreds of dollars, anything like that. So I would just Google discriminator, and you'll probably discriminator and ballast. You'll probably find the product.
okay. And so Gary, people have heard how you can switch out your refrigerator and you can get an incentive for that. You trade it out. I think that's mostly residential or small business. But is there something similar for HVAC systems? Do you know? A few more details about any incentives or offerings they have for HVAC systems?
Yeah, so I say typically, smaller businesses are going to have HVAC systems that would qualify for Energy Trust standard incentives. So like a package unit, for example, there's different incentive amounts available depending on the size of the package unit. So, it starts at maybe a couple $100 for a smaller system, and then up to like 25 tons, which is pretty good size. You're getting hundreds of dollars back for that unit to go with high efficiency unit versus standard efficiency. So as long as there's kind of some forms and paperwork that needs to be filled out. Often an HVAC contractor can help out with that. we can kind of help out as far as letting you know what efficiency requirements are. And it's just kind of a processing of the incentive form, stuff like that. So it's pretty straightforward for most systems that are that we're going to see in small and mid-sized commercial businesses.
And you talked about occupancy sensors, Garrett, and I know that there's a button that you can turn it on and off. What's the difference between turning them on and off versus letting them just do their own thing when you walk in and they don't come on? What does that mean, and what do you recommend around that?
So it's basically just a manual override. So you know, a wall mount, switch mount, occupancy sensor. It can act. Many of them act as just a manual on-off switch. So you can kind of override that. It's, you know, and that's it's not necessarily a bad thing. So like maybe the timeout is 20 minutes on an occupancy sensor. If someone, you know, leaves the room and they know it's going to turn off in 20 minutes, if you know no one's going to come back and you can turn it off, it's just more potential savings. So it's just kind of two separate controls for the light.
Do you know if there's an online calculator that someone can enter an HVAC model number and to find out how efficient it is? I guess similar to the EPA refrigerator calculator.
I do. I can get back to that question. I can't remember who put that out off the top of my head, but I know there is a calculator out there. I'll need to get back to the person that asked that question.
Yeah, and we can follow up with everybody in case anyone else wants to know where they can find that. So, but you could probably go to I guess if people don't know and there's no label on the refrigerator or HVAC system, you could look up the model number and find out more about the efficiency on it. You just go to where you purchased it or online somewhere.
So yeah, with HVAC units, usually you can get the efficiency manufacturer data from the manufacturer. On older equipment, sometimes there are some guides that actually give you the existing efficiencies, and then like I said, there's some calculators available where you can estimate savings. I know Energy Trust gives some estimated savings, and they have a booklet listing their incentives, giving the estimated savings for particular upgrades or particular units of different sizes. So that's available in their standard incentives booklet. So that gives you a rough idea how much savings you'll see.
Great. Thank you, Garrett. And that was the last question, but we will stay online if anybody else has further questions. But thank you again for joining us today.